Hi everyone, so we're back at it in another video. This time we're going to be looking at taking a second derivative using implicit differentiation. And we're given x squared plus xy plus y squared equals 7. Based on this information, we have to find the second derivative d squared y dx squared at this point, 1, 2. And of course, you can check that the point indeed does satisfy the equation just by plugging it in. Right, 1 plus 2 plus 4 is indeed equal to 7. So let's see how we're going to do this. Well, we can start by finding the first derivative, right? The first derivative, to do that, we just take the derivative with respect to x of this entire thing, and that'll give us 2x, 2x plus y plus x dy dx. And this part over here just comes, of course, from xy. When you're differentiating that with respect to x, we use the product rule, and so we get the derivative of x with respect to x, which is 1 times y, so that's just y, plus x times the derivative of y with respect to x, which is dy dx. And then we've got y squared, so this is just going to give us 2y and then dy dx, and that's by the chain rule, right? So if any of this doesn't make sense, try it yourself and see. And hopefully you can get the right side pretty fast. It's a derivative of a constant, so that'll just be 0. Oh, sorry, this applies, the operator applies to this entire thing, and this is the result. We're not taking the derivative of this is the derivative. I just messed up with the notation. Anyway, proceeding from here, let's see what we want to do. We want to isolate dy dx, right? So let's see how we can do that. Well, this isn't in dy dx, this isn't in dy dx. So let's bring them over to the other side. And then we have x plus 2y on the left hand side times dy dx equals negative 2x plus y. Okay, now with that we've managed to find the value of dy dx. And so, well, no, we're not there yet. We've got dy, so if we divide by x plus 2y, then we will have successfully isolated dy dx, and that'll be negative 2x plus y over x plus 2y. Okay, first step is done. We can definitely plug in 1, 2 and find dy dx, right? Remember the question is asking at this particular point, 1, 2. But we're not asked to do that. We're asked to find the value of the second derivative at that point. So we need to take the derivative of this. So that's going to be the derivative with respect to x of dy dx. And what is this going to be? This is going to be, of course, well, if you do one thing to one side, you have to do it to the other side as well. And so that's going to be the derivative of this. All right, plenty of ways to do this, but either way, it's going to be pretty messy. So let's dive in and see what we get. So take out the negative first of all. So this is what we want, so we don't need to worry about the left hand side. Right hand side is our main focus here, and lots of things we can do here, I guess. Okay, just for the fun of it, quotient rule, I don't really like it because there's a lot of stuff to do. You have to memorize, or you have to remember whether the numerator or denominator is differentiated first. So let's skip that. Let's actually make it a little more unique, and instead write this as negative d dx, right, of 2x plus y times x plus 2y to the negative 1, right? And now there's some chain rule action going on as well. So the inner function is x plus 2y and the outer function is x to the negative 1, or like something to the negative 1. Okay, now let's see. So we've got a product over here, but it's just a slightly messy product, right? We can work with that though. So what is this going to be? Well, we keep the negative. We take the derivative of 2x plus y. What is that going to be? That's going to be 2 plus dy dx. Yeah, 2 plus dy dx times x plus 2y to the negative 1. Now we take the derivative of x plus 2y to the negative 1. What is that going to be? That's going to be, we're adding it, but when we take the derivative, it's going to become negative x plus 2y to the negative 2. What is that going to be? That's just going to be something over x plus 2y squared. right? So I'm kind of reverting now from the negative notation to over something to the positive power, just so that it looks a little neater. Nothing complicated there. And now we have to take the derivative of the inner function, which is going to be 1 plus 2 dy dx. Now remember when I said earlier we can find dy dx at this point and be done? Well, yeah, I guess I should have done it then because it's going to come in useful now. Let's just go up here, right? The point is 1 comma 2, plug it in and see, because all we have to do now is plug in the point 1 comma 2 over here, right? Just plug it in here and see what we get, because this is the expression for the second derivative. We don't have to write out the entire expression, thankfully. We can leave it at dy dx. So let's just plug it in and see. What is it? It's 1 comma 2, and it is negative 2x plus y over x plus 2y. So negative 2x plus y. Make sure the negative is here and not here, because that obviously changes things. So negative 2x plus y over x plus 2y. What is this equal to? This is equal to negative, and then on top we get 2 plus 2, which is 4, over 1 plus 4, which is 5. So this is the value of dy dx. Now we need only plug this in. I'm going to zoom out a little just so it's easier. All right. So what do we have here? We have 2 plus negative 4 fifths. So that's going to be 6 fifths times x plus 2y. That's going to be 1 plus whatever, 1 plus 4. So that's 5 to the negative 1. That's 1/5. All right. Minus, here's where it might get a little messy. Let's see, 1 plus 2 times this. So that's going to be 1 minus 8 over 5. Okay. Already not the nicest. Now what is x plus 2y squared? X plus 2y squared is just going to be what? 5 squared, right? Yeah, 25. All right. Okay, now it's just very simple math left to be done. So we have negative 6 over 25 minus what? So what is 1 minus 8 over 5? That's going to be negative 3 over 5, right? Over 25. So what is this? This is negative 6 over 125, but you have to multiply by 5. So I'm just giving them a common base, minus negative 3 fifths. So we're going to make that minus negative 3, which is plus 3 over 125. Right? So just bringing them both to a common denominator of 125. What is this? This is just negative 30 plus 3, so negative 33 over 125. However, we don't need to leave it like this. We can take out, oh no, yeah, we do. 33 is 3 times 11. There's no 3 or 11 here. So this is our final answer. And with that, we're done. So hope you enjoyed. Hope you got the same answer. In case I made an algebra mistake somewhere, please do forgive me. It's very possible that I did. Oh, wait. Did I? Yeah, I might have, but this is the general idea. So yeah, let me know if you got another answer in the comments, because I have a feeling I might have made a mistake somewhere in here. If you catch a mistake, extra credit for you. And yeah, just let me know in the comments if you got the same thing or not. But not the most fun of questions. It was pretty, ugly at times, but we got through it. So thanks again for watching, and I'll see you in the next video. Bye bye.